Welcome to a talk about portability from Unix Windows using Gentoo. My name is Michael Haubenwallner, just call me Haubi. And I'm working at SSE Schäfer IT Solutions, a company that merged last year from Salomon Automation with SSE Schäfer PEM. And yeah, this one. What I'm going to talk about today. Of course, there is a challenge behind. Then there is a difference in the requirements between application and the developer. Another thing is the difference between Unix and Windows. Fortunately, there is Cygwin to fill the gap in between. But still, Cygwin has a problem with package managers. As a solution for the portability problems, there is Gentoo prefix. Another helper utility is Gentoo parity. And then I'm talking about the few next steps I already know that have to be done. And finally, I'll try to show a demo video. Initially I planned to do the live demo, but this would rely on a stable internet connection. For the challenge, when SSE Schäfer is creating a warehouse for a customer, like this one, or not like this one, but similar, there is a software necessary to run this warehouse. This software is called WAMAS, short for Warehouse Management System. This is a challenge by itself. I'm not talking about, but another challenge is a warehouse usually does run for a long time, up to 20 years, sometimes even more. This is true for the software as well. Because of being a software, it does need an operating system to run on, which of course needs a server. The challenge here is, which operating system would you choose where you can provide 20 years of support for? Well, actually, within 20 years of software, and I'm working for a little more than 20 years already at SSE Schäfer, I have seen lots of different operating systems. Some of you may remember a few things like HP Unix, AIX 4, 5. AIX is still active with AIX 7. Of course, there is Linux, the different variants, Red Hat, SUSE, and the most wrong one, the most foreign one, is Windows Server, actually. So, how to overcome this changing operating systems within 20 years? Well, one could think of server virtualization, but this doesn't help to remove the dependency on the operating system. But fortunately, almost all of the software necessary to build and run the application when using open source software actually do support all or almost all of those operating systems. So the solution here is to create a custom GNU distribution that does run on top of these operating systems. But first, let's have a look at the different requirements for the application and the developer. The application does need the operating system. An operating system that suffices would provide a file system, some kind of networking, some kind of IPC, and of course process control. The developer, on the other hand, it's not the developer that needs the operating system, it's the development environment. The developer expects from a development environment, of course, an editor for the source code, a build system to create the application, a debugger. Unfortunately, developers don't have just to develop, but they also have to debug their developed code. And to be able to debug the application, the developer also needs the application runtime environment. And this is the reason why the developer also does need an operating system. In a more specific detail, the application prefers to run on the vendor supported, on the vendor provided part of the operating system, and prefers to be built using the vendor supported toolchain. That is, as a company selling software, it is quite crucial to be able to buy support from the operating system vendor. So, yeah, there is, if you use a toolchain, just a GNU toolchain on AIX or on Windows, you won't get support from the operating system vendor. Another point is when using the vendor toolchain, there are tools that provide integrity checking, which one we'll see later. For the developer, on the other hand, the developer prefers an operating system independent software to build the application and the libraries. Then operating system independent scripting languages. For most of the time it's glue code to glue various build systems together. And for all those dependencies necessary for the application, it is quite crucial to have a package manager, which ideally works at the same time or provides the same user interface independent of the operating system. However, the debugging experience is more important to be smooth and working with the toolchain than to be operating system agnostic. So what's the choice? What are the choices for these requirements? For the application-specific part on Linux, of course, it's quite easy. There is the GNU toolchain. For integrity checking, there are things like Valgrind. And debugging, of course, is done with GDB as the backend, as the real debugger. And the developer can choose whatever GUI he prefers. For Unix, this is quite similar. Fortunately, the GNU compiler is able to use the vendor-supported bin utils. This is mainly the assembler and the linker. Difference is in the integrity checking tools. They usually work when using at least the vendor bin utils. Sometimes there are problems when using GCC as the base compiler, but usually they work. And fortunately, even GDB does work so far on these operating systems. But then there is Windows. The native toolchain here is the Visual Studio compiler, available as a command line compiler cl.exe. For integrity checking, there is application verifier, and of course, the Visual Studio is a quite good debugging IDE. For the developer, the operating system independent choice, the software chosen here needs to be highly portable. I have found the GNU build environment, AutoTours, Makefiles, and of course GNU libtour as the most portable software found so far. The same applies to scripting languages like Bash, Python, Perl, and similar. And Gentoo Portage is the so far portable package manager, because it doesn't rely so much on the operating system, except for the file system, but of the build instructions. So the real important thing here is the build instructions to be working for any target operating system. But still, how does Windows apply here? Or the other way around, how to apply this choice to Windows and Visual Studio? Well, getting a step back, what's the problem with Windows actually? Looking at these build tools, GNU tools, they do highly rely on the POSIX API. So let's have a look on the POSIX API. And here is where Cygwin comes into the game, which is actually a wrapper for the POSIX API on top of the Win32 API. Looking at the requirements from earlier, Open is for the file system, and Cygwin is able to just map them to Win32 API. The same applies to networking and IPC, but this is only partially true for process control. Windows, to create new processes on Windows, there is just the create process, probably with an extended version, and it's only spawn, POSIX spawn in the Unix world that does quite the same as create process. But exec and fork, known from the POSIX API, there is no direct opponent in the Win32 API. So Cygwin does introduce a Cygwin process ID and need to work around missing functionality in Windows, but it still is able to provide a working fork so far. But then the Cygwin fork as of now does have problems with package managers, because the prerequisites to fork work out on Windows is that the child process created as a normal Windows process requires the identical process memory layout than the parent process. Cygwin actually does start the child process from the original executables, does suspend the child process, copy the memory from the parent process to the child process, and resumes the child process. But this works only if the binaries are identical. On the other hand, the package manager, his job is to replace even those binaries, actually replacing whole packages including the binaries, while still using fork to run maintenance programs. So you see the gap so far? But there is help. There is a workaround for this problem, and that when Cygwin is to create a new child process and detects the original binaries are not there anymore, Cygwin now, or there are patches to actually do so, they are not released in Cygwin yet, to temporarily create an application directory, put the original executables and DLLs there, combined with a Windows-specific DLL redirection file. This is an empty file with application executable name .local. So this forces Windows to load the DLLs necessary by the application to look in this very directory where the .local file is residing. On a detail, this temporary application directory resides in the var/run cygfork directory, and the original binaries are provided there as NTFS hard links. These patches are expected to be released as Cygwin 3.0 because the Cygwin developers find this is a new feature worth bumping the major release number. Now for Gentoo prefix. Who already knows Gentoo prefix? Oh, quite a lot. I'm not going to talk in detail about Gentoo prefix, just that it is working because most or of the GNU packages do support to install into whatever directory you want. And this is the configure argument -- prefix, hence the name Gentoo prefix. I did a talk 3 years ago on Gentoo prefix and how to provide a long-term support in sense of 20 years support using Gentoo prefix. But still, the question for Windows and Visual Studio. Okay, for Windows now we have Cygwin, but for Visual Studio there is something really new. There is Gentoo parity. The Gentoo parity is a wrapper around the Visual Studio compiler command line. It does use the Visual Studio toolchain, the command line utilities, CL, link, lib, and the like, while providing a GNU-like command line to the build tools, to the GNU build tools. So there is a command, basically parity GCC, which understands -shared, for example, to create a shared library, does wrap this one to the Microsoft toolchain, and does create a real Windows-only DLL, or same for the executable. Additionally, Parity provides a loader library, which provides features like run path embedding, as well as preloading. We'll see that later in the demo. While still Parity is a Cygwin executable. It is available on GitHub in the Gentoo space. Recently I've put it there as Gentoo Parity. So there is a new answer for the Visual Studio question. This is called Parity. What are the next steps? For Gentoo Parity, it is not yet there. It is not yet compatible with the MinGW toolchain, which is not the native Microsoft toolchain, but still creates Windows binaries. And the loader library does not use the Microsoft support for by link.exe to support a helper function for delay loading DLLs. Hopefully, when switching to the linker supported delay loading, this will simplify the porting to 64-bit. For Gentoo prefix, there is something different. There is prefix chaining. A short note here is you may have realized that the Windows does not provide the fork except without Cygwin, but when creating native processes using the native compiler, the target binaries are not Cygwin binaries, so the target binaries are not able to use fork. They just need to use the Windows API. Fortunately, there is prefix chaining, which is able to maintain another Gentoo prefix, but which does not contain the package manager itself, Gentoo portage. Instead, there is a Cygwin prefix, which contains the package manager, and prefix chaining does tell this package manager to manage a different prefix, which holds only binaries created by the native toolchain. This is similar to cross-compiling, but actually it's not cross-compiling because the created binaries can be executed within the original build environment. It's kind of multi-lib because it's on the same architecture a different variant of libraries or binaries to execute. But still, it's not multi-lib because it's in a different prefix, so it's not merged into the same prefix as the original Linux multi-lib does. And as of now, there are min-GW keywords in Gentoo, but they refer to the real min-GW toolchain and not to parity for the moment. I'm planning to use min-GW keywords with parity, because the idea is basically to have Gentoo parity as a plug-in replacement or for the min-GW toolchain. But we're not there yet. Of course, there are libtool patches that do support using parity. Actually, libtool does support using the cl.exe toolchain already, the Microsoft toolchain. But it's different and quite incomplete. Without wrapping the Microsoft toolchain, you cannot do a few features libtool usually relies on. So there is of course need to patch libtool to use the parity toolchain. These parity libtool patches are not integrated into Gentoo prefix yet and are not yet submitted upstream, because parity is still under development towards the min-GW toolchain. I can't promise, or I do not expect actually, to reduce the complete need for patching libtool when parity provides the full min-GW toolchain. I don't expect this would work, but it could be. No, I don't think it's possible. But finally, the goal is to build more libraries using the Visual Studio toolchain within Gentoo. For a demo video, let's see how that works out. I have set up in a VirtualBox a Windows Server 2016 with standard Cygwin setup plus the Cygwin SSHD. On this Windows, I have installed all the Visual Studio versions from 2008 to 2017. I have set up a Gentoo prefix as the 64-bit Cygwin prefix in /FOSDEM Gentoo, and I have set up a chained prefix using the Cygwin prefix from FOSDEM Gentoo to manage the Windows prefix in FOSDEM Windows. Let's see how that works out. I'm SSHing into the Cygwin or the Windows box, the Cygwin box actually. Here you can see this is vanilla Cygwin 2.9, and I have started this Gentoo prefix. Now I'm going to replace a DLL used by the currently running bash. Currently running is the prefix bash. The DLL I'm going to replace is cygintel, and I have navigated already now to the location of this cygintel DLL. Is this readable so far? Nice. So the next step is to replace this DLL with the Cygwin provided DLL. It's a different file, but provides the same API. And now, we're using the vanilla Cygwin DLL. You can see how it breaks. Why does it break? It does tell quite nice. The different the current shell does fork or wants to fork to execute the ls process in the child. But Cygwin realizes that one of the DLLs necessary to start the Cygwin, this new child process from bash, detects that this DLL, while existing, is loaded to a different address compared to the parent process. And this is the reason why Cygwin fork currently breaks. But now I'm going to restore the original DLL for now, but now I'm replacing the Cygwin DLL with a Cygwin DLL containing the fork patches. Oh, this is one thing not so readable. Here I'm stopping the SSHD within Cygwin. Then there is so there are no Cygwin processes running, so I'm able to replace the Cygwin DLL. Then I'm replacing the Cygwin DLL with one that supports these so-called fork cables hard links, and starting the SSH daemon again. Now navigating again to this very same, I'm doing this very same again, navigating to this DLL to replace. Here you can see this is not vanilla Cygwin, but Cygwin with additional patches. I have called them the Gentoo patches, or actually I do need a different name. So here there is still the backup and the original DLL. And now, LDD $bash shows this is still to be loaded. Then replace this DLL with the Cygwin one, so it's actually a different one. And now ls or bash is able to fork even with the replace DLL it does need, and execute ls in the child process. This is necessary for Gentoo portage or for a package manager running inside Cygwin to work out, because as already said, package managers do replace DLLs and execute tables and the like. How does this work? Let's inspect this var run cygfork directory. There is a directory per user and a directory per application. This application directory does contain the bash.exe, the original executable, does contain the original DLL and the bash.exe.local file, which can be empty. This is the DLL redirection file. This is how the workaround actually in Cygwin can work. And the patches are basically accepted upstream and pending for the next major release. Now create some application. I'm going to create a simple application here, C++ application, and going to compile it once with the Cygwin compiler, and the second time with the Visual Studio compiler wrapped by parity. It's quite simple. The difference to see is between Cygwin and the Visual Studio executable. Cygwin does mangle the 0 argument for the executable as Unix path, while the Windows binary encounters the real Windows path. And the application I created just prints this 0 argument on standard out. Compiling this application with Cygwin, does yield the POSIX path, because Cygwin does mangle this one. And unlike on Linux and Unix, it's not a.out but a.exe, the default output name. Now entering the Gentoo prefix where parity is installed already. Parity is able to find the installed Visual Studio versions from the registry, which is easily accessible through Cygwin using /proc Cygwin. Here you can see there is Visual Studio, this is 2008, this is 2010, then there is 2012, 2013, Visual Studio 2013, 15 and 17. So there are their product title does include a year name, while the compiler internally just has an increasing number, except for the 13. They do like like the airplanes where you don't have a seat number 13. Now we set up parity to use the newest Visual Studio by default. Again, it is querying the registry for available Visual Studio and does set up configuration files to use this Visual Studio. Compiling the application now looks quite similar to done with Segwin. It's just a different host triplet called i686 PC Win32 and G++, which actually is just a command line provided like GNU compiler. The backend called is the Visual Studio compilers. Here we can see the 0 argument is the full Windows path because it is a native Windows application. The Segwin LDD for that Windows executable, well, is able to find some DLLs, some native Windows DLLs, but the Segwin LDD is not able to read those manifest embedded DLLs. This is like the side-by-side application provided by Windows. Segwin does not use this one. Okay, now for a shared library. Creating a simple library that does not so much do. Then returning 17, a header file, and using this library function in the main application file. I'm going to show beyond the creation of a shared library, also how that there is the parity loader library, which is able to listen to the elder library path environment variable, for example, beyond others. But first, I'm going to compile this with the Segwin compiler again, with G++ dash shared, output file name .so, lib.so, and the source file. And finally, again, linking the final application, just specifying this library. Executing does work so far. Yeah. Now I'm moving around the DLL into some subdirectory. Actually, this is the .so file is the real DLL for Segwin. After moving the DLL away, Segwin is not able to find this DLL again. Well, actually, it's Windows not able to find the DLL. But because of Windows, using the path environment variable, pointing to the new directory does find the DLL again. However, with Segwin, it does not work to use an elder library path to find the DLL. Let's compare this with parity again. The command line is pretty much the same, except for the host triplet. The created files, there is the .so file, lib.so as the output file. This actually is the import library. And additional creation is the real DLL. This is called lib.so.dll. Again, the same command to create the final application does work as expected. Now moving this native Windows library around. Actually, I have to move the DLL away. And now, as expected, the application is not able to load this DLL. Of course, because of being Windows, using the path environment variable to point to the new DLL location does work. But also, you can see it is even the library path environment variable, which is interpreted by this loader library provided by Parity, that does find the library again. Let's have a look at the files created so far again. The lib.so actually is the import library. This is quite similar to an archive file in Cygwin. This is the Cygwin file command, which just knows about archive files, while the DLL file actually is the Windows DLL. So now I'm going to merge zlib, because it is a small library, in the Windows prefix, which is managed by the Cygwin installed portage. I don't recalculate dependencies, but this is portage doing its work for Windows. Zlib, the build system of zlib, actually does not know anything about Windows. It does know about MinGW, but nothing about Windows. And actually, this build system here does the very same commands as it would do on Linux. The only difference here is some uname, but I'm not sure about how this actually is used. Parity still provides fallback for i586 PC Cygwin triplet for Win36.1. This is actually the profile still used in Gentoo prefix as the Win&T profiles. Then the zlib build system, actually zlib configure, is asking the compiler if the compiler is able to produce a preprocessor error. And the error message shown by Parity, or the Visual Studio actually, you can see these are real Windows paths. And this is the full path to the source file, provided to the Visual Studio by Parity. Continuing, testing if a few header files do exist. They are provided by Parity as well for things that do map to Windows actually, and are available in Windows often with a leading underscore, like Win32 provides the underscore open core, which does basically the same as the POSIX open core. But back to compiling. The makefile used with zlib just runs the compiler, uses the original GCC command arguments, including the GCC extension -include. -include with GCC does include the specified argument, specified file, before processing the real source file. Parity actually does create a temporary source file, put this -include file setconf.h there, and first, and second, it puts the original source file there. It is a temporary source file, and the Visual Studio compiler does show this source file name on the standard out. Here you can see there are 3 jobs running in parallel. Okay. For the linker line, this is a real Linux link line -shared, the original cflags, output file libz.so with the version number. Yeah. Let's look at what has been installed now. So probably the colors are not that readable. First, a real file that is libset.so.1.2.11. This is the import library. Then there is libset.so1.2.11.dll as the runtime library. And there are symlinks, libset.so, referring to the import library. Same for libset.so.1. Actually, this feels somehow wrong. And additionally, there is a libset.dll.lib symlink for compatibility already with the min.gw variant in libtool, which does look out for linking shared libraries using the name scheme libset.dll.lib. So that's it so far. For a summary, going back to the different requirements for application and developers, the portable build environment to provided or using the POSIX API on Unix and Linux, it's quite easy using the host libc, and on Windows the Cygwin DLL. For the operating specific tool chain, which is needed for to provide a GNU command line. On Unix and Linux, it's GNU CC using native or GNU bin utils, and on Windows there is Gentoo parity wrapping Visual Studio Compiler to provide the GNU CCC command line. Questions?
You don't use the Visual Studio IDE to compile or build?
No.
Command line, and then if you want to debug, you have no solution for us. You have to attach to the process and rely on.
No, you can run. You can run the application from within the Visual Studio IDE. It just isn't used for compiling. However, I have done it in a different project. You can configure Visual Studio as an nmake, the Visual Studio as an nmake project, and actually run the Cygwin make to run the Cygwin build environment using parity as the wrapping compiler, provide creating the final Windows binary, and tell the Visual Studio project this is the output file, the executable, and can debug normally in Visual Studio. Yeah?
Did you try running Gentoo in the Linux environment that the newer Windows had?
I have tried, but the Windows subsystem for Linux has two major problems here. First, it is not able, or it was not back in time I tried it at least, to call Windows binaries. So you cannot run the Windows compiler from within the Windows subsystem for Linux. This is the first problem. The second problem is, you may remember this is a Windows Server 2016, and as far as I'm aware of, the Windows subsystem for Linux only is provided for Windows desktop systems. Yeah?
When you're listing the compiler versions to use, can you use eSelect instead of parity setup instead?
This is the idea. Oh, maybe I should remember repeat the question. Whether the question was if we can use eSelect instead of parity setup. Actually, the idea is to use eSelect here. More?
I have a question related to performance.
Yeah.
How does your application behave when you compile your own version of Python instead of using the one provided by Cygwin, for instance?
The final application runs on native speed because it is compiled as a native application. Oh, repeating the question first, probably. The question was for the speed of the application when built with parity. And the answer is it's a native application. So when there is performance tuning necessary within the application running on Windows. It's performance optimizing as you will do on Windows with any application. Yeah.
And maybe another question: Can you use all the options in, well, for instance, in the /c/core/make.com? Can you use all the, for instance, if you want to customize your own the make options and compile in Perl, can you do that with under prefix?
The question was if we are able in Gentoo prefix to use all those Gentoo specific options or Gentoo Portage specific configuration in /etc. Actually, yes, we can. It's a Gentoo system. It's Gentoo Portage. Yeah, it's a Gentoo system. There's quite some few minutes left. Otherwise, no more questions. Otherwise, yeah. Oh, one more.
Is your company the only user of this method, or are there other users of this method to compile?
The question is, if it's only this one company using this system, or if there are other companies. Actually, there are no other users yet, probably, because this is something I create within SSI Schäfer. And for example, I am a Gentoo developer as well. So I'm able to develop Gentoo prefix, including the parity wrapper within the Gentoo community. And actually inside the company I'm the first user. For Gentoo prefix, there are of course users, but I don't know if they are company-wise or just normal users. But there are quite a few Gentoo prefix users. Not for Cygwin yet, because this is quite new, and especially not for the Windows yet, because this is even newer. But yeah, there are a few people interested in using Gentoo prefix on Cygwin already. Yeah.
When updating a Cygwin application like Bash, that would be in a different folder, so Portage doesn't interfere with the package management of Cygwin itself. Or if I run both in one prefix, if I run Portage in the same prefix where Cygwin installed packages, then I would effectively have two package managers messing around in the same file system.
Yeah. So the question is, if there is a problem when Gentoo prefix does install binaries applications into the same file system directories as the Cygwin package manager, well, the question here is, the idea of Gentoo prefix is to not mess with any system directory, but Gentoo prefix does use its own otherwise empty file system directory, not touched by any system package manager, and does install the Gentoo distribution, Gentoo prefix distribution, inside this one file system. No one else should touch this one. Okay. Otherwise, thank you very much.